Hello, thank you for joining our webinar, Safety and Handling of Permanganate. I am Liz Mueller, our Direct Marketing Specialist for Carus Corporation. A few housekeeping items before we introduce our speaker. The phones have been muted to help with the background noise. Please feel free to type in questions as you think of them in the question feature of the GoToWebinar. We will have time for questions and answers at the end. If we do not get to a particular question, we will follow up directly with you after the webinar. We will email a PDF version of the presentation to all participants within 24 hours of the conclusion of today's webinar. I would like to take this time to introduce our speaker, Mr. John Boll. John is currently the Technical Service Manager for Carus Permanganate Business Group. John has been with Carus Corporation for over 40 years, serving in a variety of sales and marketing positions. The Technical Service Department provides chemistry and applications customer support, including on-site lab testing and plant-scale startup and troubleshooting services. John earned his BA in Engineering from Purdue University, West Lafayette, Indiana. He is a member of the Water Environment Federation, WEF, and the American Water Works Association, AWWA, where he served as the AWWA Illinois Section Chair from 1992 to 1993.
Good morning to everybody who's attending the webinar, and good afternoon, I guess, to those on the East Coast. Our intention is to provide a broad overview of important safety issues and to explain how global harmonization requirements have impacted permanganate products going into 2016. Chemical safety is a complex topic, and there are many components with it. And our seminar should address a variety of important topics ranging from regulatory standards, worker exposure, chemical reactivity, disposal of waste, and ultimately to the disposal of empty packages. And as Liz indicated, I'll cover as many of these topics as I can in the next hour. But also remember, we have many safety experts on staff who stay up to date on the newest information, and they can always be consulted at any time after the completion of this webinar. And we will try to answer as many questions at the end as we possibly can. So by way of introduction, I'd like you to know that Carus Corporation is a member of the American Chemistry Council. And as a member, we participate in the ACC's Responsible Care Initiative. There are several important principles that form the program, but none are more important than to protect the safety of our workplace staff and also our customers. Today's program is one of our ongoing customer safety communications efforts. So to start, I want to first re-emphasize that in today's presentation, we are focusing on our permanganate product line. Permanganates are part of a broad chemical category identified as oxidizing agents, and it is also a manganese chemical. The properties of oxidizing agents and manganese compounds drive the rules that govern permanganate safety, safe storage, transport, handling, and disposal. Permanganate products are manufactured, packaged, and delivered in primarily two forms: crystalline solids and concentrated liquids. They are similar in that the active ingredient, which is the permanganate ion, is the same regardless of the physical form of the product. However, they are different in concentration of this active ingredient, varying from nearly 100% as a dry product to 40% or 20% as a water solution. These changes in form and concentration will drive the speed of permanganate's reactivity and the associated cautions about its handling and use. Since potassium permanganate is in its dry crystalline form as the highest concentration, the most severe precautions and warnings are generally associated with this product. If we begin by agreeing that really the first steps of worker safety is knowing the risks, how it can hurt you, and how it can happen, there are really three situations that define the potential hazards of permanganate use. In the first, hazardous events occur when permanganate reacts unintentionally and rapidly with some other substance. Unanticipated reactions with incompatible materials are typical. This situation is potentially hazardous when concentrated permanganates are mixed together with substances that they chemically react with. Because permanganate is concentrated, a mixture such as this generally will generate and release heat. Just a quick reminder, permanganate does not react with all substances, only a select group of reactive materials. The second situation is hazardous events occur when large amounts of permanganate are released to the environment. Environmental hazards may occur because a large release may adversely affect aquatic life, or if improperly disposed of, can in fact result in the first situation of unanticipated reactions. And finally, hazardous events occur when a worker is accidentally exposed to permanganate, especially the eyes. Regarding human safety, exposure to permanganate may be internal by ingestion or inhalation, or external, such as exposure to skin, eyes, or clothing when handling or due to spills and splashing. Most of the health effect hazards are associated with daily, chronic, long-term exposure, such as in our manufacturing facility. For most users, short-term exposure issues are more important when we're talking about sensitive tissue, such as the eyes may be exposed and result in injury. Worker protection equipment is always required. Communicating the potential hazards and precautionary actions, worker safety, worker protection, specific worker protections, and remediation options is accomplished through a variety of different methods. In addition to seminars such as this one, the common routes are shown here. As our understanding of product applications evolves, or as regulations change, these communication routes may also be reformatted or revised. And that really brings us to Globally Harmonized System for Hazard Communications. Today there is a drive to consistency or harmonization in the way information is delivered worldwide. Our presentation today is in part designed to inform you of changes that have impacted permanganate product safety. The safety data sheet is still our most important safety literature piece. As of June of last year, the GHS compliant safety data sheet replaces the previous material safety data sheet, MSDS. This switch to a new name really signals that there have been changes. For example, there's a new 16 section format to the SDS, although Carus has been using this 16 section format for some time. Of particular note, red, black, and white pictograms are now part of the new format as well. The safety data sheet is available for crystalline permanganate, and all of the precautionary information relates to this dry material. Remember that when it is stored and handled properly, it is stable and easy to use. But it is an oxidizer, and if the dry powder is mixed with incompatible materials, it will generate heat. However, when it is dissolved in water as a dilute solution, all acute hazards are pretty much eliminated. It's also self-limiting because at room temperature, the strongest solution you can make is 4% by weight. Water is your friend when you're working with permanganate. A new safety data sheet is also available for permanganate liquids, and all of the precautionary information relates to the concentrated product as it's delivered. As with dry permanganate, when concentrated liquids are stored and handled properly, they are stable and easy to use. There are no vapors that are released from permanganate solutions. And concentrated liquid permanganate is an oxidizer, and if mixed with incompatible materials, it will generate heat. However, when it is dissolved in water as a dilute solution, most immediate hazards are eliminated. Again, water is your friend when you're working with permanganate. This slide shows the new health hazard pictograms that are required for crystalline Carus potassium permanganate products. These pictograms apply to all package sizes. The health and safety categories are also new, and they are based on the latest research data. If you would like to know more detail about the category definitions, the OSHA.gov website will provide all of the appropriate tables. Carusol liquid permanganate also has new health hazard pictograms, and these pictograms apply to all package sizes. Again, the health and safety categories are also new, and they are based on the latest research data. In addition to the new pictograms, signal words, hazard statements, and precautionary statements are new to permanganate labels. They are designed to better define the health and safety impacts of the product being used. If signal words are required, there are only two choices to choose from: warning or danger. The signal word for permanganate is danger. This is the permanganate precautionary statement. The wording is specific to permanganate, and it is linked to the physical hazards associated with handling oxidants, and in particular, permanganate. This is the health statement for permanganate. It reflects the potential health hazards as well as the oxidizing chemistry of permanganate. For example, it identifies the fire hazard potential of oxidation. This is a new pictogram for permanganate, and it's the only environmental hazard that applies. Because permanganate's environmental impact is related to the quantity of material that may be released, this pictogram is applied only to large package sizes. Lastly, this is the new GHS pictogram that reflects the oxidizing nature of permanganates. The physical hazard criteria are available if you would like to see more detail. Now I want to transition to the important discussion of worker protections. The safety data sheet still contains recommendations for personal protective equipment. By following these recommendations, exposure is minimized or eliminated, and health hazards are negated. So let's look at each one of these in detail. First, the inhalation exposure scenarios for permanganate products, for the most part, apply only to the crystalline powders. When transferring the material from its package into a storage hopper, a fine dust can be released. This caution also applies to any situation where dry permanganate is air conveyed into a storage silo. It may be possible, however, to imagine a situation where a fine mist of liquid permanganate is generated and a worker may be exposed. This would be rare, but could occur if the concentrated liquids are being spray applied, or if a pipeline under pressure has a small leak or cut. Permanganate dust is an irritant, and breathing it should be avoided. The eyes are very sensitive tissue and must be protected from permanganate dust particles and liquid droplets. Dry permanganate crystals are sharp and abrasive and can scratch the eye's surface. Plus, the crystals carry a small amount of alkali from the manufacturing process, and the permanganate might react with eye tissue, forming alkaline products. This alkali could produce a corrosive burn. Eye protection is very important, and I would specifically mention that safety glasses with side shields are acceptable when handling dry permanganate, but that our most recent recommendation is to use goggles when handling the concentrated liquid permanganates. Permanganates will react with the skin oils, producing a brown stain. Highly concentrated permanganate liquid may attack the skin or other contamination that may be on the skin. Gloves should be worn when handling permanganate. And as with all chemicals, concentrated permanganate products should not be eaten or ingested. I now want to discuss how to properly store permanganate products and the potential hazard conditions that you should be aware of. Permanganate products are manufactured and packaged in containers made of compatible materials. When permanganate is repackaged into smaller container sizes, the proper container materials must be used. Under normal conditions, permanganates are very stable and have a shelf life of many months. Cautionary statements regarding proper storage reflect the concerns of accidental leakage or spills from the original packages and mixing with incompatible materials on the warehouse floor or drainage system. In a warehouse, be aware that lift truck forks may puncture a permanganate package, and permanganate that leaks from a damaged container can react with lift truck brake fluids or antifreeze on the floor or decking of a trailer. Keep permanganates separated from heat sources, other organic chemicals, and concentrated acids. In recent years, dry crystalline potassium permanganates, along with many oxidizing agents, has been added to the list of chemicals that could possibly be used by terrorists to produce a dangerous reaction. The CFAT standard limits the quantity of permanganate that can be stored at an industrial site where there is inadequate security in place. The maximum quantity is 400 pounds. Following a top screening, where proper security measures have been verified, inventorying large quantities may be permitted. Municipalities are exempt from the CFAT standard. Our authorized distributors comply with this standard by installing property fences, security gates, and surveillance cameras. As I've mentioned, permanganates are normally very stable. They are also not flammable. However, when an oxidizing agent such as permanganate is involved in a fire or if they're exposed to a heat source, they may decompose. This decomposition releases oxygen, which will help to sustain and accelerate a fire. Fires involving permanganate cannot be extinguished by smothering with inert foams. Only water is effective. The Nfpa hazard code is used to communicate valuable information to first responders. Of special note, the Nfpa health hazard code has been revised for permanganate, and it is now a category 3. This reflects that irritating byproducts may be formed during a fire. Remember that you cannot smother a fire involving permanganate because oxygen is being liberated. If a fire occurs and permanganate is involved, large quantities of water must be used as the extinguishing medium. The Hazardous Materials Information System the HMIS label, is similar to the Nfpa fire diamond. While the fire diamond is designed primarily for emergencies when information on short-term effects of exposure is needed, the HMIS color bar label is not for emergencies but used to provide general health warning information. The health hazard category has also been revised to category 3 on this label. If dry permanganate is spilled, you should sweep up the material and transfer it to a clean metal drum. Do not return the spilled product to the original package if that container still contains permanganate. Floor sweepings could include reactive materials that will contaminate or react with permanganate in the drum. If liquid permanganate is spilled, it should be contained and diluted with water to a less than 6% concentration. The weak diluted solution can be neutralized with common dechlorinating or reducing agents, such as sodium bisulfite. Again, water is always your best friend when working with permanganate. If concentrated liquids are spilled, do not try to neutralize them directly until they are diluted with water. Do not wipe up spills, clean up drips or leaks, or wipe down equipment with a dry rag. We suggest that you have a bucket of water available and wet the rag with water. After using the rag to clean up a small spill or drip of liquid, rinse it in the water to get all the permanganate out of the rag. Permanganate diluted with water to make a weak, less than 6% solution can be neutralized by reducing it with commonly available dechlorinating or reducing agents. When the permanganate is gone, there is no purple or pink color visible. The remaining solution is non-hazardous, and it could be disposed of as local regulations allow. The neutralizing solutions can be used to remove brown permanganate stains from floors or equipment. The reaction will change the purple permanganate color to brown and then to clear as the reaction proceeds. Brown stains on hands or equipment can be removed by preparing a fresh solution of water, household vinegar, and 3% hydrogen peroxide. These materials are available in the local grocery store. This solution is not stable, so it should be made up fresh whenever it's needed. If you're transporting or shipping permanganate products, the U.S. Department of Transportation hazardous materials regulations are still in effect. When shipping permanganate, the proper packages, labels, placards, and documents must be used. Although there are new GHS requirements, the U.S. DOT still requires that the yellow diamond oxidizer label and placard be used on packages and over-the-road shipments of permanganate. This requirement may vary depending on the size of the package. The shipping documents must show the proper shipping name, the UN number, and any reportable quantity. There are 2 U.S. acts that regulate the release or disposal of permanganate to the environment. RCRA governs how hazardous waste may be disposed of, and permanganate as an oxidizing agent contributes to the ignitability of waste and is therefore considered hazardous. It may not be disposed of to a sanitary landfill. CERCLA, which governs Superfund sites, establishes the reportable quantities. Under CERCLA, dry permanganate falls into the 100 pounds or greater reportable quantity category. Disposal of clean permanganate packages to a chemical landfill may be permitted. For small quantities, destroying permanganate by way of neutralization could be a viable option for disposal. Remember to rinse the permanganate drums before they are discarded. So a lot of additional information is available. Please feel free to contact us if you have any questions. And we have time now at the end of the seminar to answer any specific questions that you may have.
Ascorbic acid be an option for neutralization.
So one of the questions that we've received is ascorbic acid one of the options for neutralizing permanganate? Ascorbic acid will react with permanganate. My recollection is that the reaction is rather slow. But I believe it would be an option. It certainly would be a compound that you'd want to keep separate from any concentrated permanganates if you were storing both of them. The pH of the system often dictates how rapidly something will neutralize permanganate. So it's possible that the reaction with ascorbic acid is really too slow.
You can mention too that we have a document that covers different compounds, different neutralizing compounds.
I've been reminded that we do have a handout sheet that we can send that lists a variety of different compounds that are used to neutralize permanganate solutions. If you would like to receive that, please feel free to drop us an email. There's a question regarding the concentration of the dry crystalline permanganate. There is a reference at one point to 95% material and another to 97% material. That's because Carus manufactures and packages a variety of different grades of permanganate. And one of the defining characteristics of those different grades is they may have slightly different assays or concentrations. They will range from pharma grade material, which is typically greater than 99% purity, to as low as 95% purity for some of the products that we supply for municipal wastewater treatment. All of the drinking water treatment chemicals are either technical grade at 98%, free-flowing grade at 97%, are the ones that are usually purchased and used in drinking water treatment plants. And the remediation is a specific category of branded products because they do require higher purity. And the remediation products are 98.8% or greater as they're delivered to the site. In a remediation application, the permanganate is being injected deliberately into the ground to destroy unwanted materials, hazardous materials. And that's why it requires a higher concentration and low impurity product. Question is, can Tyvek suits be worn when handling either permanganate powder or liquid? And the answer is yes. Tyvek suits are compatible and good safety clothing to have around to slip on easily when handling permanganate or transferring it from a drum into a feed system. We do have a question about recommending paint that can be used for surfaces that may be exposed to potassium permanganate. There are specific paints that can be applied. I don't have that list here, but we will we'll be glad to follow up with some specific recommendations on paints that we use here, both in our manufacturing plant or that we know other customers have used successfully. There's a question about materials compatibility with PVC piping. So PVC piping has been a particularly difficult issue to handle in recent years. It is our observation that PVC pipe has undergone some manufacturing changes, or it could depend on who the manufacturer is. But there are reports of a lot of pinhole leakage of PVC pipe. Our recommendation is to continue using PVC pipe, Schedule 80, and typically the joints should be welded or glued together and not threaded. But the occurrence of pinhole leaks is a little bit confusing to us, and we've been unable to really determine exactly why or when that will occur. Typically, if you run into a leak, it's usually with a fitting such as an L or a T fitting. And in particular, if the PVC product was welded together from two halves, we've seen pitting at the weld. We also have reports of pinhole leakage in straight pipe as well. And especially where it has been mounted. So we don't know if that's because of stress being applied to the pipe at that point, or exactly why it would occur at that location. But please let us know if you run into any situations with piping materials or tank materials, so that we can keep track of those and try and keep track of where those are occurring. And if you can possibly document for us who the manufacturer of the product was, that would probably help in our analysis of the situation. So there's a question about permanganate crystals and solutions and whether they can be stored and dosed in the same building as 25% sodium hydroxide or anionic polymer. Yeah, this is always an interesting analysis, because really what we're talking about primarily in this safety presentation is handling the concentrated products. So if the permanganate is stored as 100% dry crystal or as the concentrated liquids, there can be incompatibility with polymers, especially when the polymer is concentrated itself as well. Typically what will happen is, however, the permanganate and the polymer will react with each other and you'll destroy both of those particular products. But the hazard situations will probably be rare. The question is also, refers to 25% sodium hydroxide solution, and that will not create any hazard situation if they're mixed together, but you will destroy the permanganate product. If at all possible, these products should be separated, isolated, and have some kind of small damming system between them so that leakage will not be, the mixing of the two products together would not occur. Are there any other questions that we can answer? Okay, if that's not the case, then we'll end the seminar. If other questions come up later, please feel free to contact us. And Liz, if you'll go to the last slide. And here are some some contact information, including my own email, that you can use if you want to email additional questions to us following the presentation, or if you want to request any type of literature that we can provide following the seminar as well. Thanks, appreciate it.